Okay, this is it. We'll talk about laws of exponents in our discussion today. So basically, there are only 7 laws of exponents, and we will name them individually. If you can still remember, in our previous discussions, if you have this x to the power m multiplied by x to the power n, this is equal to x to the power m plus n. So this laws of exponents, or this law of exponent, this is called product of powers rule. Okay, so this is number 1. This is the number 1 rule. So it is called, okay, it is called product of powers. Product of powers rule. Okay, so that refers to this. We have x to the power m, okay, x to the power m times x to the power n equal to x to the power m plus n. So it means that if you have expressions that contains the base, in this case the base is x, m is the exponent here, base is x, n also an exponent. So when you multiply the two factors with different exponents, you simply write the common base. The common base here is x, so write it, and then after that you just sum up the exponents. You add the exponents. So this is called product of powers rule. Okay, so how will we apply this? For example, if you're given, say, if you're given, say, 4 to the power 2 multiplied by 4 to the power 5. So applying or using the law or the rule, so we simply copy the same base. So the common base here is equal to 4. As you can see, the common base is equal to 4. So just write the common base. So the common base is 4. You just write it. After that, you just add the exponents. So the exponents are 2 and 5. So 2 plus 5. Or this is equal to 4 to the power 7. Alright, so what does this number means? So this number means that the base is multiplied 7 times. So this is equal to 4 times 4 times 4 times 4 times 4 times 4. 1, 2, 3, 4, 5, 6 times 4. Which is equal to, so 4 times 4, 16 times 4, 64 times 4, and so on and so forth. So this will give us an answer of 16,384. Okay, so that's one of the examples that we can give for this first rule, no? Product of powers rule. So this one belongs to the laws of exponents. Another example is this one. If you're given 4x squared times, so quantity 4x squared times 2, or quantity 2 times x cubed equal to, so if you look at the given, so it's not exactly the same as this, okay? But take note that this x to the power m, this is understood to be, or to have a coefficient that is equal to 1 multiplied by this base. 1 times x. Here also, there's a 1 here. And the answer, there's also understood to be have a 1 here as the coefficient. So in this example, we have 4 as the coefficient of x squared. Here, we have 2 as the coefficient of x cubed. Okay, so the rule is you just multiply the coefficients. All right, so we have 4 multiplied by 2. So we multiply the coefficients and then just copy x squared. Okay, then we have x cubed. So if you look at now the given or the result, so we have x squared times x cubed. So it now follows this rule, product of powers rule. Okay, so for the coefficients, you just multiply it or multiply them. So 4 times 2 is equal to 8, and then apply the law of exponents or the product of power rule, this one, which is you just copy the common base, which is x, and then after that you just add the exponents 2 plus 3, or this is equal to 8x to the power 5. So this is our answer. Okay, so another example, if you're given, say, x cubed times x to the power 8. So very easy, no? You just follow this. You have x, the common base is x, then after that you just add the exponents. So this is equal to x to the power 11. All right, how about this example D? If you're given 3x to the power 5 multiplied by x squared, so this is equal to, so this one again understood to have a coefficient that is equal to 1. So the rule is you just multiply the coefficients, so 3 times 1, and then just copy this literal coefficients, x to the power 5 and x to the power 2. Then for the coefficients, you multiply 3 times 1 equal to 3, and then apply the product of powers rule. So we have the same base, which is x, copy the same or the common base, and after that you add the exponents of 5 plus 2, so equal to 3x to the power 7. Okay, how about this? If you're given y to the 5th power multiplied by 3y squared equal to, so again, this y here understood to have a coefficient equal to 1. So the same way as we did in the other example, so we have to multiply the coefficients. 1 times 3, and then after that you just copy y to the 5th power, then multiplied by y to the power 2nd power, or to the power 2. So 1 times 3 equal to 3, then apply the product of powers rule. So y, then you add exponents, so equal to 3y to the 7th power. Okay? And another example. If you're given 2 to the power 2 times 2 to the power 3, so just copy the same base, the common base is 2, all right, and then just add the exponents. 2 plus 3 equal to 2 to the power 5, or equal to 2 times 2 times 2 times 2 times 2, which is equal to 2 times 2, 4 times 2, 8 times 2, 16 times 2, equal to 32. Okay, so next example. If you're given, say, 2x cubed times 4x squared. So So this is equal to. So again, the numerical coefficients, you just multiply them. You have 2 here as the coefficient of the first factor. So 2 times, you have 4, and then you copy x cubed, then you copy x squared. Then after that, multiply these numbers, these coefficients. So 2 times 4 is 8. Then apply the product of powers rule. So you just add. So this is x to the power 5. Okay? Then how about this? So another example. If you are given, say, negative 8x squared times 2x to the power 5 times x. So this is equal to, again, you just multiply the numbers. You have negative 8. So these are the coefficients multiplied by 2. Then x here understood to have a coefficient equal to 1. So times 1. Then after that, you just copy the x's. We have x to the power 2 times x to the power 5. Then x to the power understood to have a power equal to 1. And multiply the coefficients. We have negative 8 times 2 equal to negative 16 times 1. So negative 16. Then apply this. The common base is x, and you just add the exponent. So you have 2 plus 5 plus 1, or equal to minus 16 x to the power 8. Okay? So this is the answer. Then another example. If you have x cubed, y cubed, then x to the power 5. So this is equal to, you just combine these two. You can rearrange their position. So we have x cubed, then we have x to the 5th power, then you have y cubed. Okay, so for the first two, okay, you have to combine them using this rule. So this is x to the, you just add x to the 8, then y cubed. Alright, so this is our answer. Now, if you're given, say, something like this, 2 to the power negative 3, then times 2 to the negative 2. So again, you just copy the common base, which is 2, and then you just add the exponents. So the exponents are negative 3, then plus negative 2. Alright, so we will now apply the rules in combining. So the rules in combining, when you add two numbers of the same sign, you just add the numbers and carry the common sign. Alright, so we have 2 to the power, you add the numbers, 3 plus 2 is equal to 5. Then the common sign is negative. So this is the answer, but this is not yet the final answer, because we have another rule or part of the laws of exponents that says that if you have x to the power negative m, this is the same as 1 over x to the power positive m. So I will just insert it here so that we can get our final answer for this. So this means that this is equal to 1 over 2 to the power 5, which is equal to 1 over, so we know already that 2 to the 5 is 2 times 2 times 2 times 2 times 2, so which is equal to 32. So this is the final answer. Now, with the help of this other rule, which we are going to discuss later. Okay, so at this moment, we'll take this, and we have something that you need to be careful of. Okay, I will add another two examples and see the difference. It looks like the same. They look the same, but they're different. Like for example here. So another example, if you're given, say, negative 2 to the power 4 times 2 to the power 2. So what's the answer? So take note that 2 is the one that is raised into 4, but we have negative here. So this negative 2 can be written as negative 1, okay? Negative 1 times 2 to the power 4, then times 2 to the power 2, okay? So be careful in this. So 2 to the power 4 is simply, we write the negative 1 here. So this is the same as, you just apply the rule, this rule. So they have the common base, which is 2. Then you add the exponents, 4 plus 2. So equal to negative 1 times 2 to the 6. So what is 2 to the 6? 2 to the 6 is the same as 2 times 2 times 2 times 2 times 2. 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. So 6 times that you multiplied 2. Okay, so 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32 times 2, 64. So this is negative 1 times 64, or the final answer is negative 64. Okay, so take note on this, because if you are given something like this, negative 2 raised to a power 4 times 2 to the power 2. So this is equivalent to, you see we have negative 2. You can apply, there's another rule which I'm going to insert here, but I will not elaborate, so I will elaborate that in the other discussion. So this can be written as negative 1. Negative 2 is the same as negative 1. Okay? Negative 1, and then we have positive 2. Okay? Something like this. Then both of them raised to power 4. Then times 2 to the power 2, which is equal to negative 1 raised to a power 4, then 2 raised to a power 4 times 2 raised to a power 2, which is this negative 1 raised to a power 4 is the same as negative 1 times negative 1, negative 1 times negative 1. Okay, so there are 4 negative 1s being multiplied, and then you apply the rule. Okay, so common base is 2, so 2 to the power 4 plus 2. So here, negative 1 times negative 1, positive 1, times negative 1, negative 1, times negative 1, that is positive 1. Okay, becomes positive 1. Then we have 2 to the power 6. So positive 1 is the same as 1, or you don't have to write this because that's understood to be 1, then coefficient times 2 to the 6, where 1 times 2 to the 6 is the same as 2 to the 6, and which is equal to 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5 times 2, which is equal to 64. So you see the difference? We have the answer here, positive 64 here, negative 64. So you have to be careful. Okay? So I think that's all for this first rule, or first laws of exponent. So it is called product of powers rule. Alright? So that's all. If you have any question, you just leave your question in the comment section below, or just message me directly. Thank you.